design of this AB in the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. We are going for the next topic of discussion, that is demultiplexer. We have started with the digital electronics and this is the topic of discussion for today, that is demultiplexer. Now we have already completed the multiplexer part, and there I have said you that multiplexers are basically it is a kind of selecting device, means it is selecting one of the input as the output with the help of select lines. But in case of demultiplexer, it is just the opposite of the multiplexer. It is also known as data distributor. It is also known as data distributor, and the function of the demultiplexer is opposite of the multiplexer. In this case, what we are doing exactly, we are having only one input, only one data input, and we'll have many of the outputs where we are distributing the same data to the various outputs. For generalization, I can have the you can have the understanding with this diagram. If we are going for a multiplexer, generally the nomenclature of this multiplexer is like 1:n, where we are having only one data input, that is D, and we are having n number of outputs, okay, n number of outputs, and we'll have m number of select lines, and the number of these select lines depend upon you can have the select line like this is S0, S1, likewise it will go up to Sm-1. So what I am telling, it is a kind of combinational circuit or digital electronic device where we are having only one data input and it is distributed over a number of the outputs with the help of these select lines. This m number of select lines are helping in order to get which of the output will be getting this data. Okay, so this is m number of select line which are deciding that this data will be transferred to which of the output. Now if you can recall, it is just opposite of the multiplexer. In the multiplexer case, we were having a number of data inputs and there we were having only one output. Select lines was able to select one of the data line as the output. Now in case of demultiplexer, what we are doing, we are having only one data input, and with the help of select line, we are finding out that this data will be going to which of the outputs. So this is the difference. I think I'm able to make you understand that in this case, we are having only one data input. In case of multiplexer, we were having a number of data inputs. In case of multiplexer, we were having only one output, but in case of demultiplexer, we are having many outputs. The number of the select lines is dependent on the number of the inputs in case of multiplexer, but number of the select lines is dependent on the number of output in case of demultiplexer. So these are the basic differences between your multiplexer and demultiplexer, which is many a times coming as a question in various semester examination, that what is the difference between MUX and DeMUX. By using the concept which I have told you right now, you can differentiate them. Now coming back to the originality, I have told you that in case of multiplexer, we were having only one data input and many outputs, and therefore it is sometimes also called as 1:many device. In case of multiplexer, that was called as many:1. Here it is called as 1:many, and the reason being only one data input, many outputs. Now the nomenclature of the demultiplexers are given as 1:n, where n represents the number of the outputs. Now number of select lines, as I have told you right now, that the number of select line depends on number of outputs. And what is the relationship? Mathematical relationship is n less than equals to 2 to the power m, where n is the number of outputs, m is the number of select lines. Now there are various types of demultiplexer that is available and that we have to study in case of digital electronics, that is 1:2, 1:4, 1:8, 1:16, and so on. You can go for 1:32 or any number of and depending on the output, we can have various types of demultiplexer. Now one thing which I have told you previously also, and here also I am just repeating it, that select lines are the primary inputs to the multiplexer and demultiplexer. This you have to keep in the mind. So these are the 4-5 points. If you will keep it in your mind, you are done with the introduction part of a demultiplexer. That multiplexer is a data distributor. It is having only one input and one data input is getting distributed over a large number of outputs depending on the number of select lines. This device is also known as one-is-to-many device. The number of select lines is depending on the number of the outputs, and its nomenclature is given as 1:n, and depending on that there are types of demultiplexer. Now once you have known this, you are done with the introduction part. You know each and everything about demultiplexer as a device. Now we will directly jump to the design part. Now I'll be telling you about one or two multiplexer. The rest will be done by you as a task. If you are finding out difficulty in that one, I will be repeating it. If you'll be commenting in the comment box, I'll tell you about that one also. But for the time being, we'll be only discussing about 1:4 DeMUX and 1:8 DeMUX if time permits. So the design process, I have already said you, the process is fixed. The first thing is to go for the block diagram. So this is 1:4. So I am keeping it as 1:4. So only one input, that I am telling it as D. Data input is only one, that is D. And we are having 4 outputs, that is Y0, Y1, Y2, Y3. The number of select lines, it can be determined with the help of number of outputs. So number of outputs is 4. So 2 to the power m equals 4. So m will come out to be 2. So therefore we'll have 2 select lines, and I am naming those select lines as S1 and S0. Okay. So this is the block diagram that you need to draw while having the design of any kind of combinational circuit. So firstly, what we have done, we have gone for a block diagram where we have shown input, select line and the outputs. Now after this, we have to go for truth table, and as I have stated you that select lines are the primary inputs. So we'll go for 2 select lines. I am telling them as S1, S0. How many combinations are possible? Tell me. 4 combinations are possible. 0, 0, 0, 1, 1, 0, 1, 1. Someone wants to write it as 0, 0, 1, 1 is also fine. 0, 1, 0, 1 is also fine. After that, we'll go for the outputs. What are the outputs? That is Y0, Y1, Y2 and Y3. So these are the various outputs of 1:4 multiplexer. Now, if the select line is 0, 0, 0, 0, then this data will be appearing as the output in Y0. This data will be appearing as the output to the Y0. So we will have D at this position. The other outputs definitely will be equal to 0 because we are having only one input that will be serving as the output. So if it is going to Y0, the rest value is going to be 0. Now after that, if it is 0, 1, we'll have D at this position and the other values are equal to 0. Next. So we'll have Y2 as D, the other values equal to 0. If it is 1, 1, we are having all the values 0, only Y3 will be D. Now once we are done with this, we'll go for writing the Boolean expression of all the outputs. So first of all, we'll write the output of Y0. So for output of Y0, you can see that all the values are equal to 0, leaving the first one. So first one, the output is D, so we'll write the Boolean expression for that one. Now the value is 0, and here it is D. So since it is 0, this one is 0, we'll have a bar over S0 and S1. So we'll have S1 bar, S0 bar, D. Similarly, tell me about Y1. For Y1, you can see that we are having D at this position, the other values are 0. So we have to just focus at this position, and you are finding out the value of S1 is 0, S1 is 0, S0 is 1. So therefore, S1 bar, S0. So S1 bar, S0, D. Similarly, we'll go for Y2, and using the same process, you will get S1, S0 bar, D, and Y3 will come out to be S1, S0, D. Now once you are done with all the values of Y0, Y1, Y2 and Y3, you can clearly see that this is the reduced Boolean expression. We cannot have any other reduction of this outputs. So once we have got that, finally we'll go for the design. And for designing, I have already said you that we'll use the pattern that we were using previously. This one is our S, okay, S1, the negation of that one, and we'll be going for other line. Similarly, we'll go for S0, will have the negation of that one and this line. Okay, now since we are having only one input, that is D, so I will keep this line as D. I am keeping this line as D, and since we do not require the negation of D, so we are not making it. Okay, now S1 S0, so S1 bar S0, so we'll have S1 bar S0 bar and D. So we'll take like this, connect it with a 3 input AND gate. This is our first output, that is Y0. Similarly, we'll go for S1 bar S0, then D. Connect it with a AND gate, 3 input AND gate. This is your Y1. Next is S1 S0 bar S1 S0 bar D. So this is your third output, Y2. And the last one is S1 S0 D. So take S1 from here, take S0 from here, take D from here. Connect all of them with a AND gate. This is your next output, that is Y3. Okay, Y3. So now if you are blocking it, you can clearly see this is if we are blocking it. If we are blocking it, okay, and make this line as like this so that it will be peculiar or visible. So this is your D line. So now you can see that we are having only one data input, that is D, 2 select line S1 and S0, and 4 outputs, that is Y0, Y1, Y2 and Y3. So I think the design is very clear to everyone. This is very simple to design. What you need to do, you need to draw the block first. After drawing this is your D line. So now you can see that we are having only one data input, that is D, 2 select line S1 and S0, and 4 outputs, that is Y0, Y1, Y2 and Y3. So I think the design is very clear to everyone. This is very simple to design. What you need to do, you need to draw the block first. After drawing when you are going for drawing the block, you will have the proper representation. One data input, 4 output, and since there are 4 outputs, we will have 2 select lines. Now select lines are the primary inputs, so we'll write S1 and S0, we'll write all the combinations. Depending on the combination, we'll have the values of Y0, Y1, Y2 and Y3 as DDD in a diagonal one. After that, I have written the Boolean expression and drawn the diagram. So that's it for the design of 1:4 DeMUX. Next is we have to go for 1:8 demultiplexer. Now if we are going for 1:8 demultiplexer, the same process has to be done and no variation other than the just the numbering. There will be no other change other than the numbering. You will be able to do it very easily. So the first thing is that you have to draw the blocks. So you are drawing the block. This is 1:8, only one input, that is D, 8 outputs, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. It will start with Y0 and it will end at Y7. I'm just putting a dot, you will be able to understand. Okay, now if there are 8 outputs, that means n is equals to m. So using this condition of select line, that is 2 to the power m equals to n, so we'll have 2 to the power m equals to 8. This implies m equals to 3. So the number of select line will be equal to 3. So we'll have 3 select lines. And what are those 3 select lines? S2, S1 and S0. Now since select lines are the primary inputs, this was the first step. The second step is to write the truth table. So you can write the truth table very easily. 3 select lines, I am taking that one as S2, S1, S0. 8 outputs starting from Y0, Y1, Y2, Y3, Y4, 5, 6, 7. Okay, we'll have 8 combinations. Those 8 combinations are 4 zeros, 4 ones, okay, then 00, 11, 00, 11, and then 01, 01, 01, 01. Now if all the 3 select lines are equal to 0, then Y0 value will be equals to D, the other values are equal to 0. Similarly, if all the values S2 is 0, S1 is 0 and S0 is 1, then in that case D value will be coming as the output for Y1. So similarly, you will have this values equals to 0 other than Y1. Similarly, you will go for 2, then for 3, then for 4, 5, 6, and last one is 7. So you can clearly see that we are getting the value of D in the diagonal. And when you will write the expression for all of them, that is y0, it will come out to be, this is simple, S2 bar, S1 bar, S0 bar, S2 bar, S1 bar, S0 bar, D. As a trick, you can remember it as key, we'll just go on writing the values of select line in terms of 4 to 1 quad as a bar or non-bar number. And after that, you just put a D, you will get the answer done. So it is y1 equals to S1 bar, sorry, S2 bar, S1 bar, S0. Y2 equals to S2 bar, S2 bar, S1, S0 bar, D. Similarly, Y3 equals to S2 bar, S1, S0, D. Y4 equals to S2, S1 bar, S0 bar, D. Y5 equals to S2, S1 bar, S0, D. Y6 equals to S2, S1, S0 bar, D6, and Y7 equals to S2, S1, S0, D. So these are the 7 outputs, and we know that all of them are in reduced form. Now once they are in reduced form, the next step is to draw the diagram like this. So we'll do that. Okay, we'll do the same thing that we were doing previously. We'll take first as S2, keep the negation of S2, then S1, have the negation of H1 by putting a NOT gate, then S0 and put the negation of that one. Now once you are done with this, we'll take a D line. I'm taking this D line like this. Okay. Now after that, the first one is S2 bar, S1 bar, S0 bar. So just take bar from every of the input, put a dot so that it can be easily visualized. Take a D from here, connect this to a 4 input AND gate. This is the first output, that is Y0. Similarly, you can go for S2 bar, S1 bar, S0. So S2 bar, S1 bar, and S0 from here. Take D from here, connect it with an AND gate. This is your Y1. Now, similarly, you can go for each one of them from Y2, Y3, Y4, Y5, Y6, Y7. I think all of you will be able to do it as I have done in the case of 1:4 DeMUX. The final one will be S2, S1, S0, and we'll take D from here, just making a dot so that you can easily visualize. This is the AND gate we are connecting, and here we'll be getting the value as Y7. The process will continue as we have done in this case. So final diagram will be looking like this. The only thing you have to fill up is to give AND gates over here and just make 4 connections. Okay, so this is how you are designing 1:8 DeMUX. The process is very simple. We have to go for 1 data input, 8 outputs. The output will decide the number of select line. By using this formula, you will be able to find out. Once you have got this, you need to go for truth table. I have told you select lines are the primary input, so just write down the select line, write there all the binary combinations, and depending on the values of 0, 0, 0, we'll have D output of Y0 and Y1 to up to Y7 depending on the value of binary count. After that, write down the outputs of each of the output, write the binary equation of each of the output, and after writing that, you need to follow this process, and by using this one, you will be able to design the MUX. Now, if you are blocking it, you will be able to visualize it is matching up with the initial diagram that we have drawn. So we'll have how many number of select lines? 3 select lines, 1 data input, and you are having 8 outputs starting from Y0 to Y7. So this is all about the demultiplexer design. I think all of you have understood this one. If you have not understood any of the part, you can write that in the comment box. And if your any prospective suggestion is for making the video more knowledgeable, you can come up with that. Thank you very much.